Mahbub is an agricultural student dealing with a massive information load. He needs to process a 1,000-page textbook, a complex land map, and a stack of blueprints and forms through a 5-inch smartphone screen. But his workflow hits a wall. He opens the Files from Drive folder and finds it empty. It's a moment of digital friction that feels like a total system failure. In reality, the files aren't missing. He's simply encountering a specific Android file picker interface that requires a manual account selection. The moment he points the software to the correct email, the list of PDFs populates. Navigating this digital environment effectively requires a specific vocabulary of tools, a set of invisible, historically rooted mechanisms designed specifically to manage this kind of information overload. The smartphone acts as a high-tech bottleneck until a user learns to navigate the specific architectural logic built into the software. Managing a massive textbook means reducing digital weight. Mahbub uses Extract Pages to isolate page 2, a first aid quiz, into a focused file. He then modifies page labels, adding a numerical prefix to keep documents in sequential order. To avoid the friction of scrolling through the text later, he creates a personalized bookmark in the outline, establishing a permanent anchor he can return to with one tap. This digital to physical translation continues with the land map. By engaging a measure tool, Mahbub uses the device as a precise architectural ruler to calculate a seedbed's area and boundaries directly on the screen. However, the map is cluttered. Overlapping notes and highlights from his classmates have obscured the actual data, making the schematic nearly impossible to read. He restores clarity by filtering the annotations. He strips away the noise, leaving only the notes from a single peer and the data points highlighted in cyan. These tools for extracting and filtering act as cognitive mechanisms. They allow a user to carve human focus out of a mountain of digital noise. The final task is administrative, a leave application form. As Mahbub fills it out, he reaches a section for demographic data. He encounters a standard interface element, an empty circle that fills with a solid black dot once selected. This is a radio button, and its design is a direct mechanical inheritance from the push-button dashboards of mid-century cars. On these physical radios, pushing one station button physically forced the other buttons to pop out. The hardware was designed to prevent the car from trying to tune in to two conflicting signals at once. In a virtual world where variables can be infinite, the digital radio button carries this philosophy forward, forcing a single, definitive human choice. Just as he finishes, Mahbub hits a permission error. He cannot save the file to the main drive. The software architecture anticipates this failure. It silently creates a secondary backup in the device's local download folder, ensuring no progress is lost to a server error. Finally, he uses a redaction tool to permanently black out sensitive personal information on his report. Features like automatic backups and permanent redaction serve as the digital fortresses that allow a user to work with total confidence. Mahbub's digital desk is now clear. The textbook is distilled, the map is measured, and the application is securely filed. These applications are the culmination of decades of physical design history and psychological problem-solving. By understanding these hidden architectures, from data extraction to the mechanical history of a button, users move beyond simple screen tapping and become deliberate masters of their digital lives.